Thank you, Eugenia. I want to make sure that you all are aware that I have my UNH library hat on. And secondly, instead of the UNH badge, I have my OLI badge. Some of you may have heard of the Osher Lifelong Learning Institute. Barry and I are trying to organize a group of OLIs into a cadre of what we like to call the Gray Panthers. Okay, and you'll learn more about that later. In addition, I handed out a business card, and all of the slides that I'm going to show you today are on the website on that that's on that business card. So there's a lot of stuff on my slides when I do them. So you'll be able to get that information off those. Okay, an axiom from Carl Sagan: extinction is the rule. Survival. I'm not used to a microphone. I'm used to walking around. Survival is the exception. So that's one axiom, and it's a true axiom. There's thousands and thousands and thousands of more animals and plants that go extinct than ever get created. Okay, a lot more species go extinct than are created. Another axiom, as presented by my good friend Dr. Rock: data collected and analyzed using science, peer-reviewed to produce information. All of you librarians sit right there at the nexus between science and survival. Because with information, this is how we have survived as a species. We've utilized what we have learned to kind of progress as a civilization. Right now, we are in the tunnel of climate change. We have a 10-year window, according to the experts, within which we have to do something to try and figure out a way to undo some of the damage we've done to our environment over the last 200 years. So once again, that is where you sit as librarians, in between science and survival. And the work that you do is vitally important in providing the information to the scientists, not only here at the University of New Hampshire, but hopefully in schools K-12 throughout our nation as well. So what I'm going to do is I'm going to talk to you a little bit about some of the things that Barry and I try and teach as part of our Forest Watch program over the years, and also why it's important. What will be our future? Oh, yeah. Data, science, wow, that's way up there. Data, science, information from the air. If you look at this little chart right up here, you can see that there's kind of a balance between the amount of CO2 that goes in and out of vegetation on land and the amount of CO2 that goes in and out from the ocean. But for the last 300 years, we've been adding the excess in the form of fossil fuel. And in so doing, we have created this dilemma, the dilemma of carbon dioxide in our atmosphere, going up, up, up. 300 parts per million or billion, I can't remember, parts per million for over 800,000 years, right? But in the last couple hundred years, or not even the last couple hundred years, just since 1960, we have gone from roughly 300 all the way up. Actually, we're to 400. I apologize, Eugenia. I got to remember the microphone. We're going all the way up to 400. So that's a 33% increase. Permafrost, okay, thawing permafrost, information from the land. There is methane in the form of undigested, unrecycled, undecomposed plant matter that's been stored as permafrost for thousands and thousands of years. And that 92 gigatons actually represents about 18% of all of the carbon dioxide that we've added to the atmosphere since the beginning of the first industrial revolution. This is some imagery, satellite imagery, that kind of shows the changes from the 1950s in the amount of sea ice. And note that sea ice does not, as it melts, increase the volume of water in the ocean, to what the projected sea ice will be in the 2050s. Okay, and you can see a significant difference, white being the thickest sea ice. And then up here, you see the changes in basically the same thing as monitored by the Cryosat, which is an European Space Agency monitoring satellite. Data science information from the oceans. As the oceans warm up, they dissolve more carbon dioxide. More carbon dioxide means the oceans become a little bit more acidic, and as they become more acidic, the kind of critters that get to live in them start to change. And we're moving from fish to jellyfish. Don't too many people eat jellyfish. In addition, you get, as the oceans warm up, you get increasing in sea level rise. Satellite imagery, although not as easy to see, but this shows sea surface temperature off of the Great Barrier Reef in Australia. The warmer water affects the reef in the sense that what it causes is the 15-minute growth. It causes the coral to begin to bleach. Coral are a mutualistic organism. They have a blue-green algae inside them that helps them photosynthesize and get their food. But when they warm up and the ocean acidifies, they kick them out. They kick out the zooxanthella. And in so doing, they bleach, they turn white. And right now, they say that roughly 50% of the Great Barrier Reef is dead. The Great Barrier Reef, something big enough to be seen from the space station, is dead. Dangerous situation. I put this little thing on there because when I went to look this up, right, the Earth Observatory portion of the NASA data set gave me a message, an error message, that said that, well, we're sorry, but that information is no longer available. And it made me think, oh, it's got to be the Trump, right? But no, this actually occurred in 2013 with a Senate and a House that was under Republican control. So this actually, the funding was cut out in the Obama era. So sometimes you have to go to it's cute, it's called the Wayback Machine. You might have seen this, Barry or Mike. And it's where somebody has stashed all this NASA data. So it's kind of cute. Disasters cost money and they kill people, right? From roughly 1980 to 1999, there were roughly 79 total billion-dollar disaster events in the nation, adjusted for CPI at 2016. In 1 year alone, in 2017, there were 16 total events at a cost of $309 billion. Okay, that's almost the same amount of value that was present in the disaster events in 20 years, from 1980 to 1999. So we're getting hammered, folks. We're in the tunnel. A friend of mine lives in Iowa, and her parents just went through their second 500-year flood in 10 years, okay? But still, her parents, well, you know, it's just the way it is. It has nothing to do with climate change, has nothing to do with any problems with the future of the Earth. California's Camp Fire, satellite image of that, right? You can see it from space. Oh, I forgot to note the satellite image. This is in Missouri River in Nebraska. You can see a before and after. The value of satellite imagery is its change over time. You can, for free, you can get and download, it's called Google Earth Pro, or Google Earth Pro engine. And in so doing, you have access to how many years worth of data, Barry? Does it go back? Since '82. And so you can literally, with students as young as elementary school students, you can go for 30-some years worth of data watching the change over time in the Amazon basin or in the African rainforest, wherever you want to look and see what's going on for free. And so that's a critical tool that's available for everybody to use. Plus, we lose a lot of people, 100 lives lost just in the last 18 months from these events. I got involved with Barry in 1986, and this was the moment in time some of you remember when we lost Krista McAuliffe and the Challenger. And in so doing, I was just devastated. I was a teacher, a colleague of Krista's, Concord High School, and I wanted to do something to change that. Because, once again, data and science was available the night before the launch to tell the NASA administrators that it was a 57% chance of critical failure if the temperature didn't increase by the next day. A 57% chance of critical failure. And the NASA administrators chose to ignore it. And as Barry will tell you, or I will tell you now, it was primarily because Reagan wanted to tout the Challenger and his State of the Union, because it was the same night. Okay? So, I mean, we ignore science at our own peril. Like I said, all these images are on the website. So, that summer, 1986, I went off to Goddard Space Flight Center. And I listened to a man named Jim Hansen talk about the graph that I've already showed you there, about carbon dioxide, and the fact that it was going to radically affect the climate of the world in years to come. And he also talked about the fact that there was this a program, the International Geosphere Project, and they were going to, as Michael told you, they were going to put space-based platforms up there for monitoring all manner of things on the Earth. And in order to do that effectively, though, you also had to have ground truth studies to validate what the satellite remote sensing was showing you. And it wasn't rocket science what this ground truth was requiring. It was just going out and taking some simple measurements: temperature, collecting plants, measuring the damage on the plants, measuring the amount of spectral characteristics in the plants. So it wasn't overly difficult to do. So I thought to myself, well, why can't we get a research scientist with a project who would like to have an army of student volunteers to serve as their ground truth specialists? And I wrote letters all over the place, right? And finally, serendipitously, as I was tearing up a newspaper to start a fire one winter, I learned about EOS, the Earth, Ocean, and Space Institute here at the University of New Hampshire, and my handsome colleague friend over here, Dr. Barry Rock. So I wrote him a letter, right? And it was the first letter he opened after moving here from JPL. And he wrote me back and said, yeah, let's give it a go. And we started a program called Forest Watch. And Forest Watch, at its heyday, had over 350 New England and all the way down into mid-Atlantic state schools trained in a series of field-based protocols, laboratory-based protocols, and satellite remote sensing protocols. And the beauty of Barry Rock was there's no pretense about this man. He's got the doctor in front of his name. He's world famous. He's talked to presidents about all manner of forest decline. But he also can make a kindergarten teacher feel confident that they can do something with their students that is authentic science that will become published in an annual report, and the students and the teachers loved it. And for 23 years, Forest Watch worked. 23 years. Of course, the year that he retired, the president, I won't say his name, at the time of the University of New Hampshire, decided that we weren't going to have Forest Watch anymore because Barry couldn't write grants to fund it. Forest Watch also gave rise to a number of iterations. Iterations being so successful that they're still going on. Although I think Barry told me Project SMART is not going to happen this summer. Is that correct? Okay. Project SMART is for 10th and 11th grade students, and they work with research scientists, sometimes doing work that even undergraduate students at UNH don't get to do. Watershed Watch, also here at UNH, was a cooperation between Elizabeth City State University and UNH, monitoring the Great Dismal Swamp of southern Virginia and northern North Carolina. World Ocean Watch, Barry and I started with a friend of ours, Pachi Pastor, to monitor mangroves down in the Florida Keys and in the Miami Beach area. Still going on. This is the Celebration of the Sea organization that Pachi started is our 501c3 for SOS STEAM on your business card. And finally, in 1994, Barry was contacted by Al Gore, VP at the time, because Al Gore had learned about how successful Forest Watch was, and we wanted to make sure, he wanted to make sure that his international program got off to a good start. So he asked Barry to be the first senior scientist in the GLOBE program, and it's international in over 129 countries, and millions of students have benefited from an association with GLOBE. And finally, SOS, Success on STEAM, Barry and I, when he retired, we learned about a program from MacArthur Foundation. They were giving away one $100 million grant. So we applied for it. There were 1,000 applicants. We didn't get it. They're applying, or they're advancing another $100 million this year, but we have bigger goals. STEAM is successful, SOS STEAM is successful. Teachers and students, once again, these slides are on the website. Teachers and students work together as scientific colleagues with research scientists here at the University of New Hampshire. Same thing. STEAM, right? They do all the aspects of STEAM, the science, the technology, the engineering. We include the arts, the visual, the language, and the performing arts, because that is the key for the interpretation of what the students have learned, so that they can provide that information to their parents to perhaps win their hearts away from this climate denial philosophy to a climate change supporter. Same thing also on the website, right? But basically it's showing you that we're working together, trying to promote K-12 STEAM education. At the same time, we want to try and reforest the world. And why do we want to do that, right? Why do we want to do that? Why do we want to do this reforestation? Well, the primary reason is because if we can get 1 trillion trees growing, 1 trillion trees growing, we can take away 10 years worth of carbon dioxide emissions into our atmosphere. 10 years. We have 10 years to get the job going, and if we can get those 1 trillion trees planted, and we're looking to the gray panthers, moi, for $1 trillion to try and help promote that. So any of you know, a lot of gray panthers promote SOS so that we can provide that opportunity. 1 trillion trees. Oh, last thing I'll say, this young man, Felix Finkbeiner, he started a program when he was 9 years old to try and get those 1 trillion trees planted. He already has 1 billion in the ground. 1 billion trees planted. Everybody knows Greta Thunberg, the young student who promotes a way of trying to get action on global climate change. Basically what she says, hope is great, but action is much more important. When we have action, hope will be all around. Thank you.
Philip, thank you. From one gray panther to another, right? I've been here at UNH for 32 years and came here because the Challenger disaster ended the research that I was able to do at the Jet Propulsion Lab. I was doing mostly shuttle-based ground truth activities. I'm trained as a botanist and a geologist. So with the name of Barry Rock, if I just spell Barry a little differently, it would work really well. So I'm here to tell you about remote sensing of forest health, Mike has already done a wonderful job of giving you a grand overview of remote sensing. I'm envious of his drones here. When I was doing this work, when I first arrived here, I guess drones existed in the military, but they certainly weren't available for civilian use. So I'd just like to point out how beautiful our planet is. And I get to deal with these images every day. And the planet is always changing. You see different cloud patterns, but I'm always just blown away by how beautiful this planet is. Has anyone here seen the National Geographic series called One Strange Rock? A few hands in the back. Should be more hands, because One Strange Rock is planet Earth. The 4 inner planets are rocky, something you can stand on. Jupiter, Saturn, Uranus, and Neptune, all gas, nothing to stand on. And none of the planets are as unique as planet Earth. And we'll talk a little bit about how we taught students to do that. Eugenia already mentioned that we met at the, as part of the university's Research and Engagement Academy. I had never met a librarian before, and I assumed when I said, Eugenia, she'd go, shh. Well, I learned a lot from her. She's one of the many Conan the Librarian defenders of science. I mean, it's, you're turning red. Sorry about that. Well, here's me. I'm 12 years old in this picture. The arrow points out which one it is me. I'm wearing a space helmet. It's a Buzz Corey Space Cadet helmet. And my brother Don is wearing that crazy little hat that the actors are wearing. I assume this is Buzz Corey. This was my absolute all-time favorite television show. I would watch this every Saturday morning from 10:30 to 11. And I had to go down to my aunt's house because it was the only television in South Barre, Vermont. So this is 1954. I had dreams of being an astronaut, and I came close. I got to be a research scientist at the Jet Propulsion Laboratory and was there from 81 through 87. But remember, the Challenger was lost on January 28th of 86, and the shuttle program went into mothballs until they figured out what had caused the problem. And so I ended up leaving the Jet Propulsion Lab and I'm from Vermont, and I wanted to get back to New England, and I had the opportunity to come here, which was just wonderful. This is me, right there. I'm using a questionable portable field spectrometer. The thing weighed about 140 pounds, and it was portable in the sense if you had a pickup truck to carry it around in, it worked. Otherwise, you had a bunch of grunts who struggled with it. So at that point, I was learning to use the reflectance patterns of vegetation. And these are reflectance of light coming either from the sun or from an artificial illumination source of some sort. And in learning that spectral language, I was actually learning to read the language of light coming from the vegetation. And trained as a botanist, actually a plant anatomist, someone who makes thin sections of leaves, I can tell you all about the mesophyll, the palisade, the spongy, the xylem, the phloem. I had a colleague that called phloem phlegm. But if you know anything about plant structure, those are important parts of the leaves, but I had no idea that the leaves were presenting a language of light being reflected. Okay, so I learned to do that. As I mentioned, I worked with several different sensor systems that were in the cargo bay of various space shuttles, got to meet a number of shuttle astronauts. It was a boyhood dream come true. So that was great until, of course, the Challenger was lost. So then I switched to using systems like Landsat, ones that Mike mentioned, that are polar orbiting satellites. They pass up and around the planet, and the planet is rotating from west to east, and the planet rotates so that every 16 days, that Landsat takes another image of Barrie, Vermont, or Durham, New Hampshire, or Moscow, or your hometown. And Phil Browne mentioned Google Earth. Google Earth purchased all of the Landsat data, thousands and thousands and thousands of images, and have put them online for free. And you can look at what your hometown looked like in 1982, and then in 88, and then in 92, and then all the way, year after year after year, and it's all free. So you can literally do the same sort of things that I have spent my lifetime learning. You can do it for free and with no training at all. So Google Earth is an amazing tool, and as librarians, Phil pointed this out, it would be a good idea to let people know that. The spectrometer got smaller and smaller so that we could carry it around. This is a spectrometer called the Visible Infrared Intelligence Spectrometer. It would cover specific wavelengths of light. We called it the virus, and it was used in virtually all of the studies that I got involved in once I came here to the University of New Hampshire. Mike showed you a picture of some of the spectral curves. I don't want to give you a stomach ache or a headache at this time of day, but what we see are wavelengths here from the visible portion of the spectrum out into the near infrared portion of the spectrum, out into the short wavelength reflected information or region. And then here would be relative brightness. You can see vegetation is really dark in the visible because chlorophyll is absorbing all of the blue light and the red light and reflecting just a little bit of green. That's why the veggies look green. Once you get out into the near infrared, you have blindingly bright vegetation. It's a good thing we can't see that. We'd have to wear sunglasses just walking in the woods. It would be annoying. And then as you go out to longer wavelengths, the reflectance decreases. And you can see up here what's causing it, the pigments. I mentioned chlorophyll for the visible cell structure. Remember I talked about mesophyll and xylem and phlegm? All of that you can detect literally from 500 miles up. It's mind-boggling. And then out here is water content. And if you're a botanist and you can get information about pigment content, cellular structure, water content, whoa. The world is your oyster or apple or whatever. So I will be talking just a little bit about some of the reflectance properties. This would be that language of light that I mentioned before. It turns out that here in New England, we're at the tailpipe of the nation. We get everybody else's weather patterns and their pollution, and for reasons that I won't explain right now, they all converge right here where you are. Fortunately, today the air is nice and clear. Given the fact that we get our weather from everyone else and our pollution, it's not uncommon to have a very high concentration of ground level ozone on certain days when it's hot and sunny, just the day you want to go to the beach. They tell you stay inside. If you go to the coast, ozone levels will be through the roof. Don't breathe if you're there. And so it turns out that in Forest Watch, the white pines are very sensitive to ozone, and conifers, spruce, hemlock, fir, they are all sensitive to ozone. And so in Forest Watch, we selected a white pine. We can see a couple of white pines right outside of the room here. Every school had at least 3 or 4 white pines in their schoolyard, and the students could look for symptoms of ozone damage. That ozone comes from a combination of things. It will come from nitrogen oxides. I have a Prius that has a license plate that says low NOx, and that's because hybrids emit much lower levels of nitrogen oxides. They combine with volatile organic compounds coming from the trees in the presence of sunlight and high temperature. Just when you want to be at the beach, they generate ozone. And ozone damages our lungs, damages leaf, mesophyll, that sort of thing. One of my very first studies was on Camel's Hump in Vermont. I know 1 or 2 of you are from Vermont. It looks sort of like a camel's hump. Became the poster child for acid rain in the 1980s. I climbed Camel's Hump with my dad and my brother often, growing up in Vermont. And when you get above about 3,000 feet, this is at 3,100 feet, you see a lot of dead trees and a lot of yellowing of the foliage. And that's telling you that the trees are being damaged by something. One of the things the trees are very good for is they are time machines. They give you in their increment cores an indication of what climate changes there are, looking like healthy here and then all of a sudden shutting down about 1968 on through to fairly recently. And so that is another way of remote sensing, isn't it? You're sensing the change over time. One of the things we taught our students in Forest Watch to do, and I do in my own work, is start off with a macroscopic, what you can see with the eye, then select a branch. This happens to be a red spruce with needles. Take a razor blade, cut the needle, and then study it with a microscope and see what's going on inside the needle. This shows you a fairly healthy spruce needle. This would be a mesophyll cell. You see the chloroplasts here, that sort of thing. A nucleus is over here. However, when some damaging factors, and ozone is one of those damaging factors, enters through the stomates of the needles, you can see you go from healthy to very heavily damaged. And you end up with a lot of dead cells. That's not a happy needle. It's not going to be photosynthetically active. Remember that we said this is where the pigments are, this is where the cell structure is. Turns out that cell structure damage causes this dramatic drop in reflectance in the near infrared and a change in the water content. The needles dry out, they become non-functional, they're in a heap of trouble. And then on Camel's Hump, if we went to low elevations, about 2,800 feet, we saw healthy cells. This is a cross-section of a spruce needle. But you get up about 3,100 feet and you see damage. This is a stomate, and whatever damaged this mesophyll came in through the stomate. So we know it's a gas. And what gas is out there? Ozone. Okay, so this is ozone damage. We thought it was acid rain damage, but it's really ozone damage. You can then take this information, you pick up on the ground with ground truth spectrometry, and then program the satellite data to show you where the heavy damage is. And this is Camel's Hump, this is the upper hump. You can see all of the damage here is on, you see north up here. This is on the western side of the mountain. The eastern side doesn't have the same damage. And the 3,000 foot mark, it's hard to see, but this red is above the 3,000 foot mark. Everything that's green is below the 3,000-foot mark. So we could determine what the cause was, where it was coming from. It was coming from the west. It's hitting the west side of the mountain, not affecting the east side. There's just a tremendous amount of science that can be done if you just use your eyes, if you're just observant. The other thing we found is that 3,000-foot mark marks the beginning of the atmospheric sewer. And that's where the ozone is traveling, that's where the nitrogen oxide is traveling, that's where the acidic cloud moisture, you see a nice cumulus cloud that's fluffy on top, is flat on the bottom. That's at 3,000 feet. It's just the way our atmosphere works. And the highest acidity, or the lowest pH, is right here at the base of these clouds. And so during a sunny day, you get sulfur oxides, ozone, nitrogen oxides, and then on a cloudy day, they get bathed in nitric acid and sulfuric acid. I mean, it's not rocket science to figure out what's going on. But it took us going to orbit to be able to see that big picture. I'm going to finish with just a few words about studies done elsewhere and primarily in the Czech Republic. I had the wonderful benefit to live in Prague for a year on a Fulbright. It was just an absolutely amazing experience, and I wanted to see if the same problems that the red spruce was having in New England were also problems with Norway spruce in the Czech Republic. And bingo, it was exactly the same thing. So it's clearly a global challenge. Just show you a little bit about the Czech Republic is right here. Slovakia is over here. Remember, it used to be Czechoslovakia, and then that changed. Here's Prague, and these mountains right here on the border with former Eastern Germany, they're called the Kružní hory. In German, they're called the Erzgebirge. Both of those mean metal mountains, and the metal would be the ores roamed even the Romans used to mine these ores, copper, lead, zinc, that sort of thing. That part of Europe was known in 1988 as the Black Triangle. The Czechs are right here. These are sulfur dioxide emission concentrations. This was a bad place to live. It turns out that the average life expectancy in the Czech Republic in these years was 31 years. You didn't get to be my age. And it was just all of that crap in the atmospheric sewer that they were inhaling. It didn't help that they were smokers. But the problem was very significant. And this is what the trees look like in the Kružní hory. In Vermont, there were a few. Here they're all dead, and the young'uns coming up are all yellow. That means they're low in chlorophyll, and they're on their way to dying as well. And there were a number of efforts by the Czechs and the Poles and the East Germans to replant with young saplings. And those saplings looked great coming out of the greenhouse. And then they weren't going to get to be good sized. So we were able to use our satellite imagery to look. I'll just point out that this boundary right here is the conversion from communism to a democracy. And what are shown here in the colors are sulfur oxide emissions, nitrogen oxide emissions, and then particulates, solid particles. And notice how that conversion from one form of government to another changed everything. And the levels just dropped and dropped and dropped and dropped. And as Philip mentioned, as I've mentioned, as Mike mentioned, satellite data are acquired every year, every 16 days, so you can really mark changes that are occurring. This would be a Landsat image from 1972. This is the same area, Landsat image in 78. Here it is in 85, and here it is in 90. And the area that's really heavily damaged is right here, that was all forest in 72, and more than 50% of the forest was lost over that short period of time. Satellite images, you've got 30-meter pixels. 30-meter pixels about the size of a baseball diamond. Don't know if anyone here is a Red Sox fan. This is not a good year to be a Red Sox fan, by the way, but about that size. And even with that coarse spatial resolution, the fact you've got that incredible spectral coverage and you've got every 16 days automatically acquired. It just is amazing. It's a tool waiting to be used. And you can easily pick out spectrally the healthy forest and the damaged forest because of the band combinations that we generated here. This just shows you the amount of forest cover lost between 72 and 89. And you can also pick out that 3,000 foot mark. That's the 1,000-meter mark. And that's where the greatest amount of change is occurring. We then, in 1998, did a series of overflights with hyperspectral coverage. Mike mentioned hyperspectral coverage. That's with hyper, lots and lots and lots of colors. And it was my joy. I brought along an Indiana Jones fedora because I knew I was going to be flying in this Russian troop carrier, an Antonov II. And they let me sit at the controls with my fedora on. A high point in my career. In the belly of the aircraft, you've got these sensors that are stuck. This is a hyperspectral sensor. It's from the Goddard Space Flight Center. And the amazing thing was, we were able to use this Antonov II. It's a bi-wing, very stable, fly at low altitudes, almost a drone, Mike, almost a drone. We could fly at about 2,000 feet above terrain, of course. That's important. Very, very stable platform. And had we done that just a decade earlier, it would have been an act of war, and we would have been shot out of the sky. So just to show you how dramatic that change from communism to democracy was, just absolutely amazing. Phil has already told you a good deal about Forest Watch. I won't say more about it other than a 6th grade girl designed this patch. We had thousands of students, hundreds of teachers involved. It just was wonderful getting the kids outside, making measurements of trees, coring trees. I didn't want to take the time. I'll do it if I have time at the end. An increment corer, looking at the time machine that a tree represents. It was just wonderful. From Forest Watch, I'd been here, we started Forest Watch in '91. I had been here for about 4 or 5 years, came here in '87, and started Forest Watch with Phil's help and his students and all of his connections with teachers. And Vice President Al Gore learned of Forest Watch, and he actually sent me a letter asking if I would be interested in possibly serving as the first senior scientist for GLOBE. And GLOBE stands for Global Learning and Observation to Benefit the Environment. It is an international program. It's in over 135 countries around the world. It is just amazing, and it's all based on the same hands-on stuff we developed in Forest Watch. This just repeats that. It's K through 12, it's STEAM, got some great examples of student artwork over here. It works with very young students, with older students, It's just amazing, and Globe still exists. So if you've got a high school student that comes to you and says, you know, I'd kind of like to do something hands-on in science or maybe math or, you know, all of the STEAM disciplines, tell them about Globe. Maybe contact their teacher. Teachers often don't know about this. So I'll just finish, and I know I've got 15 minutes to go. So I am going to show you how to use this device. I think of myself as the Lorax, right? Turns out that the Lorax says, I am the Lorax, I speak for the trees have no tongues. We call them leaves. And they tell us everything we need to know about how happy or unhappy a tree is, and a forest is, and a whole region is. And so I'll just follow on what Phil has to say. We really need to know that there is no planet B. We may go to Mars, but we're going to be really disappointed when we get there. Mars is not a place we want to terraform or, you know, turn. Anyone here see the movie The Martian? Yeah, wasn't that great? And the hero was a botanist. Yeah. Ooh, doesn't happen often. Laura Dern was a paleobotanist in Jurassic Park. That's the only other time a botanist was featured. Star power. Okay. And why we want to do it for the kids, the decisions we make today will impact their future in a big way. And I'll just put in a little note about climate change. I created a document called the New England Regional Assessment of Climate Change and Variability. That was back in 1991. And at that time, we projected that the changes we're having today, we wouldn't see for 70 or 80 years. And we're seeing them now in essentially 30 years. I would have never dreamed that possible. I didn't really expect to live long enough to see them. And I sure don't want to think about what my grandkids are going to have to be dealing with. And that bit about 10 years is real. We are out of time. And we can use remote sensing to tell us how the forests have changed in those 30 years until now. And the changes are not good. So, but I didn't want to end on a downer. So let me tell you about an increment core. I was going to bring some tree ring cores, but I found out that I'd loaned them to my grandson. He's a senior in high school and will be coming to the University of New Hampshire in the fall. This is a hollow tube. It's got threads up here and very sharp on this end.
Looks like there's some birch all around us here, right?
Say it again?
It looks like there's birch all around us.
Yeah, we could do that. Are you volunteering, Philip? Yeah. This is an amazing tool. How many of you have used one of these? Aren't they amazing? They impressed kindergartners, they impressed the parents, they impressed graduate students. It's magical. So we've got a tree trunk, and we're going to push that part that has the screw part and the sharp end, and we just turn it. Ow, 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 ow. Okay, and you see it coming out over there? Yeah. And you put it in about that far. Then you take something called an extractor, and you put it in under that core that is now in the tube. Put this all the way in, then you back it out one full turn, and you take out the extractor, and laying on that extractor is all kinds of information about the history that tree has gone through. And when you pull it out and that core first shows up, there's this audible, like they didn't think it was going to work. And then you bring it out further and they're going, ooh, ooh, and they want to touch it. You don't do that with the Florida poison tree, by the way. It's the big brother of poison ivy. But this is a very, very useful tool, and it's a great way of doing some remote sensing of what that tree's life has been. And then if you couple that with the language of the leaves, and it's just amazing. And I'm sorry that I'm ending early. I'd like to bore you a little bit longer, but I think I'm good. I can quit. Okay.